Okay, so next up we have Loius Scott from Chemo Advisors, and he will talk about the NAG library with Clang.jl.
Good afternoon. So we're having a little bit of technical difficulty. This is what I normally use. It's about 3 times as thick as what most people own. But I've poured coffee on it, I've dropped it, and I've let 3-year-olds play with it. So I do most of my work in Linux. I'm using Windows 10 machine, which I have no clue as to what to do with it. So if you guys bear with me, I'll walk you through my education in learning Julia. I should say a few things about page down. Does that not work? Yeah, well, I'm trying to space bar. Which one's that? Shit. No? I'm not getting anything. Yeah. Shit. All right. So very quickly, a few things. Why Julia? I'm a user of MATLAB since probably the very beginning. And I'm a convert, like many people. And my elevator pitch is quite simple. I have to tell Julia, no, n equals 1, because it naturally wants to do things on as many cores as I have. That's actually not strictly true, but I tell that to people because that's actually much truer for Julia than it is for any other environment that I've had the pleasure of working in before. I should say that this is a practitioner's talk, so I'm a 20-plus year professional in quantitative asset management. And how that differs, I think, from people who are in academia is that when I make a mistake, there's 100 million notional behind it, and I have to go tell clients that I just lost 2 million, or they made 2 million. But in either case, the only thing that can happen on our side is we'll lose money. If it goes to the client, they get to keep the extra 2 million, and then we correct the error. Or we have to reach into our own firm's pockets and pay them the 2 million. So from that perspective, we have to be very, very careful about the kind of code that we push out into production. And that's also coupled with the fact that unlike other industries, if we don't adapt, we die. You cannot have stuff in production that's more than a few years old. You cannot keep up with what's happening in the academic side in econometrics and how you forecast problems. And so when you couple both of those things, the need to adapt or die and the fact that it comes out of your own pockets, not anywhere else, one has to be very careful about the environment one chooses to code in. And for me, Julia represents the future of quantitative finance. It's an environment that allows us to code both very quickly, but with a sense of security as to what's happening. Now, the reason that I decided to port the NAG library is I wanted to learn the language. And what happened is I spent several years on YouTube, well, several years of the conference on YouTube, several man days, watching these guys. And I want to put them on at the beginning, not at the end. My thank is at the beginning because I'm so grateful. I am so grateful to these people for their efforts, for what they've done in the language, and for their help. But I chose to do NAG for a couple of reasons. Number one, I wanted to do a deep dive. I didn't want to learn the superficial Julia. I wanted to actually go and figure out how to do metaprogramming, how to worry about pointers when I don't want to, how to make C calls when I don't really want to play around in C. All the things that I required to do when I was in MATLAB at a much slower rate, I wanted to learn how to do better in Julia. And so NAG represented a natural problem. It's somebody, Stefan had worked on it, but let it go, and I thought it was sort of a natural way to learn about the guts and then work my way up and say that I actually learned how to use Julia. The other reason for wanting to do the library, though, is that what I said earlier about losing our money, not clients' money, from a compliance perspective, from a production perspective, from a operational risk perspective, I know I can trust what's been happening in NAG because it's been hit on for many, many years. And so for those reasons, I decided to actually pursue doing that library. Right, so I only have a few minutes, and I want to talk about a number of points. So I'm just going to hit on each one of these, hopefully, using a Windows 10 machine with, not Word, but that other thing, which I never use. So wish me luck. I just want to quickly touch on a variety of things that I worked on and how that has been helpful. Escape doesn't work. How do I get out of here? Tab, nope. Alt-tab, Okay. Can you believe this is what I'm doing? Yeah, so this is the beginning of the NAG library, and what it is it's really what, I'm going to mispronounce his name, Yinzhao, the guy that ported the GSL library, one of the people that I thanked initially. I based it on his port of the GSL library. I started from there. And so it looks superficially a lot like what he had done. You know, I have a few, you know, different ways that, you know, if you're in Windows, you're going to type it this way. If you're in Linux, you're going to type it that way. There's a few packages that I ported over using old school methods. So I basically worked off sed and awk. I didn't use the Clang yet. I just, you know, there's so much structure in the header files of the NAG library that all I had to do is use sed and awk to get most of what I wanted to do here. And since it was a learning exercise, once I figured out exactly how I wanted to structure this, then I can go off and do it using Clang. Okay. So there's only one function in here, which is the NAG license library query. So it's a shared library. It makes a simple C call to this one function that says, have I properly loaded NAG? And the query comes back, yeah, I did, or no, I can't acquire the license. And at runtime, I initialize that. Okay, that's all there is to this. So next, we're going to go look at the other packages. God help us. Where am I? I wanted to take a quick look at my notebook. All right. Shit, that's not good. Christ. Okay, let's go in here. Yay. Right. So we had earlier one of our keynotes, Nick Higham from NAG speaking, and what I'm going to use is his package for the nearest correlation matrices as an exercise. Now this is really valuable from a risk management perspective because we want to ensure that everything is positive definite, right? And one way of doing that is to use this kind of package even if you don't need it. Turns out that I have one error, so I just redid this, not having looked at it for a while, and yeah, it's not too bad. I only had one error that I have to go back and figure out why that happened, but that's fine. The NAG query says, yeah, I'm good. I was able to load that up. And I'm going to create a covariance matrix of dimension 128, which is roughly what you really do in real life. So if you've got a bunch of asset classes, you have a bunch of industries, you have a bunch of countries, and a bunch of factors that you're working on, you typically do not work on the returns to an individual asset. You work on a factor model. And so the dimensionality is roughly what this is. And I'm going to create a vector and then construct a Toeplitz matrix, which is just if you take a vector and you scoot it down the diagonal, what you've got is a symmetric matrix. And then the next thing I do is I take the fourth power of that, and these go from 1 to 1 over 2 to the n. So everything is less than 1, and when I multiply it by the fourth power, it's diagonally dominant, symmetric. That's going to ensure that it's positive definite. And then I do a simple plot of that. It makes this really pretty interference picture for the eigenvalues of that matrix. What I then do is make it diagonally dominant by employing exponentially weighted moving average along the diagonal. So I have a very dominant eigenvalue at the top, and then these things go to 0, which represents what really happens. And then that thing looks like that, the eigenvalues of that thing. So basically, what you're seeing here is the largest eigenvalue is dominated by a single asset, and then as you go to the things that go to 0, they start to spread out, which is intuitively what you would hope for. So we then create something that makes it non-symmetric. So I throw in an upper triangular matrix plus some noise. When I make it non-symmetric, that's going to move it away from being positive definite to not, and that's a problem. Okay, and we can't see what that looks like. That's really too bad. The exponentially decayed version looks similar. Let's see if this one pops up. All right. And so when we strip out the diagonal variances and look at a correlation matrix, which is what he does, that's what I get. Man, I'm screwed here. All right. And man, you can't see any of this. That's too bad. What's happening is I'm actually calling the NAG library at this point and making pretty complicated calls, which I wish I could show you. They'll be on the GitHub. But essentially what I've done is I've gone and created dictionaries of files. So I've gone and I've used a simple shell script that grabs the header files. They're so structured that I'm able to say, here's the header file that I want to get for what particular NAG library, pull out the signatures, and just grab the ones that take a double and return a double, or the ones that take a complex and return a complex. Really simple stuff. And then what I'm able to do is create a list of all of those variables that have that very same structure. And from that, I construct a dictionary inside of Julia. Inside of that dictionary, I have a for loop that says for every element in my dictionary, just spit out a C call for everything that shares that very same structure. Before that, I then say this is the name of the chapter that I'm working on, and here is the HTML file inside of the NAG website that gives you more information. So you can actually automatically, for every chapter, just ask for help. And inside of that little eval that's happening, that's iterating over that dictionary, I'm able to get a lot of information quite automatically using simple sed and awk tools and a little bit of knowledge of how to make a little bit of simple metaprogramming inside of Julia. What you don't see here is the internals of the more complicated calls to the NAG library. But what I'm able to do is take what used to be a not positive definite matrix and turn it into a positive definite matrix by moving it towards the nearest proper correlation matrix using several different methods. Sorry for the technical difficulties. I think we can end right about there and take questions on what you might imagine would have been on these slides had I been able to get it done. Thank you.
Okay, so questions? So do you actually run any Julia code in production now, or do you have any plans of trying to do that?
No, I mean, this is pedagogical. I really am trying to get a firm understanding, given that I've watched a bunch of YouTube videos, as to what makes Julia special. And so I decided to just dive down for pros, figure out how to make C calls, and give it all of the proper stuff using the metaprogramming environment inside Julia. Now that I feel I actually got it right, what I'm going to do is go back to Clang, and then I got 50 files for the price of 5. You know, I was able to figure out 5 different types of calls: a double that returns a double that returns a complex, that kind of thing. And then I create this list of the 10 or 20 functions that fit that signature, and boom, you know, I got 50 different function calls. There's 500 or so inside of the NAG library, right? So what I'm going to have to do is then go back and say, well, I got the structure right, so now I can go back and using Clang.jl just automatically try to generate how these things get spit out. But hopefully it'll help the next person who tries to import a very large library as well. Yes, sir.
Let's get the mic so it's recorded.
So I'm guessing that there are native Julia versions of almost, or a lot, or maybe a majority of the things in the NAG library. And it would, of course, be useful to compare those and just to see what, have you thought about doing that?
Yeah, that's a wonderful point. So my whole motivation was to really understand Julia and to start with something that was pretty difficult and make sure that I understood what I was doing based upon listening to David Sanderson, all these other wonderful individuals in the community. You're absolutely right, but there's a reason why, from a production perspective, somebody in an industry like my own would decide to go with NAG, because I can easily sell bringing in Julia if I say, but we don't have to change the NAG bits. You know, so there's there's a business reason for making it. But the other point you bring up is that's true, absolutely. So if I'm able to confirm that the results of the NAG library return what we know to be true, that makes a great exercise for being able to say, hey, the versions that sit inside of Julia, do they match up when we do tests? Doing our unit tests to say, hey, the answers that we're getting back from this new code in Julia confirm with what we have, and therefore we should feel more comfortable porting our production code and not worrying about the operational risks associated with porting everything over to Julia. Oh, I didn't show you, but there are unit tests in there, right? So one of the nice things is to be able to say, listen, the NAG libraries actually have their own internal unit tests and they publish the results. So all I did was port over those unit tests into Julia and then run assertions off them. There's a whole bunch of things that return, like I said, a double that return a double, but we don't really care about that. We really want to broadcast a vector. So I do the broadcasting and I'm able to say, does this thing result in the vector using more Julia internals that gives us the answer that we thought we would get? So yeah, it was a lot of fun, but to a long-winded answer to your question, yeah, there's good reasons to try to port over to Julia eventually, but you really want to compare them to results that you're very comfortable with before you do, and that's why we do it.
Okay, there was another question here, but I'm afraid we're out of time, so maybe you can discuss that after. Let's thank the speaker.